Hello. Thank you for coming to this talk. My name is John Corwin. I'm an engineer on Cloud Spanner. Today, I'm going to be presenting Cloud Spanner anti-patterns and how to avoid them. So to start off with, some preamble on what is Cloud Spanner. This is some text that comes from our kind of marketing pitch for what Cloud Spanner is and what it can do. It's the only enterprise-grade, globally distributed, strongly consistent database service that's built specifically for the cloud. Gives you the benefits of relational database structure with non-relational horizontal scale. That being said, Cloud Spanner is not magic. It does not mean that you can take any possible relational database workload and put it on Cloud Spanner and expect it to magically scale out. Today I'm going to cover some of these use cases where you need to think about ways to help structure your workload to make it scale with Cloud Spanner. So today I'm going to talk about a few different use cases. These vary in complexity. Some of them are straightforward. Some of them are a bit more subtle. I'll go into some of the details to give you the right context for each of them. So the use cases I'm going to talk about today are monotonically increasing key patterns, how to paginate result sets, how to effectively query indexes to get the best performance, patterns involving transactional lock ranges and how to get good concurrency out of them. And then I'll end with some miscellaneous tips. Okay, so jumping into the first topic. So monotonically increasing keys. Let's say that I have the schema on the right here. I have a users table. It's keyed by user ID. I have another table here where I have this user access log. I'm keeping track of when each user last accessed my system. Here, in terms of patterns to be aware of, things like timestamps, which could include commit timestamps through Spanner's available commit timestamp feature, or just a timestamp that you've supplied. Or things like auto-increment keys are things to watch out for. So why is that? To answer that question, we need to review how Spanner works, how Spanner splits your data. So Spanner automatically shards your data. This is what allows Spanner to scale. For each table that you have, Spanner will maintain multiple ranges of that table. We call these splits. It can assign these splits to different servers. As you add more servers, it will distribute these splits across the servers that you have in your instance, allowing you to scale. So here in this example, we have a key range. This is an integer key range, but this would work similarly for other data types or composite keys, where we have a range representing from basically the first possible key, negative infinity, or whatever the lowest integer is, all the way up to 3, and then et cetera. And then finally, our last split here would contain a range from some defined key up to infinity. What does this mean in terms of your performance? Spanner splits your data based on size and load. So what this means is that, and this happens dynamically. So if you have a key pattern that is monotonically increasing, this means that all of your traffic will be going to the last split, meaning that you have at most one of your servers able to actually process traffic for this. This is a non-scalable pattern that you would ideally like to avoid if you want your application to scale. So here, if I'm inserting keys sequentially, say I'm using an auto-increment pattern, everything would be hitting this last split here. Eventually, Spanner may split that out due to size or other reasons, but still, all of your workload is going to one split. We would like to avoid that. So how can we do that? There's a bunch of solutions that we can consider. One is, say that we have some other system that's generating keys for us, and it is generating sequential keys. One thing that we can do is we could bit reverse those keys. We can take that key, we can that next sequence number, we can reverse it, and we can use that as our key. That avoids this monotonically increasing pattern because the randomness will effectively go into the lower order bits, not the higher order bits in terms of sort order. Other things we can do, we can generate our own random keys. Things like UUIDs are very useful here. We can, if we have a composite key here, so take our example here of this user access log. We have a user ID, and then we have this last access timestamp. So remember, before we had the pattern of maybe we want to put the timestamp as the leading component of the key. That has our concern here around timestamps being increasing. One thing we can do here is we can put that timestamp as the last component of the key with the user ID coming first. This means that, assuming that I don't have too many updates per user ID, I can effectively scale based on user IDs and not have to worry about those timestamps specifically. One thing to point out here is that you have to be very careful with indexes as well. Kind of common first intuition here is that say that I want to index my user access log by timestamp. I should not attempt to do that by just creating an index on that access time. Indexes in Spanner are implemented as tables, which means that they have the same scalability properties as the tables of the index themselves. So we need to avoid monotonically increasing keys in both tables and their indexes. Okay. Any questions so far? No. All right. So what happens if we really need global ordering? Let's say that we actually do want to query, based on my user access log, what are the most recent accesses, independent of user? What are some techniques that we could use to do that? So one technique that we can use here is that we can hash our keys to spread out writes across logical shards. I have an example here. We have this shard ID that we've added to our base table. I'm using a relatively new Spanner feature called a generated column, where I'm writing an expression that allows Spanner to automatically generate a shard ID for me, where I'm using a fingerprint of my last access timestamp. And I'm creating 32 shards. You can see this mod 32 here. And I'm creating this as a stored column. What this allows me to do is I can then create an index on this shard and last access, effectively giving me 32 different shards of my timestamp ordering. So what does this mean? This means that with this solution, I can scale to 32 times the write throughput that I could have otherwise, without using any sharding. A natural question is, how many shards should I use? There's a trade-off here of read performance versus write performance. The more shards that I have, the more effectively I'm going to be able to write concurrently. But it does make my reads more expensive, right? So if I have, a billion shards, that means that, in order to query that, having this leading shard component means that my query won't be very efficient. It may, make this index not that useful. So in order to measure this, what you want to do is you want to do some benchmarking yourself, kind of see what write throughput you can sustain, make an estimate, and then pick the number of shards that way. One useful tip here is that when you write queries, you can actually have Spanner do this sort and merge for you. Here's a query that I've written here that if you look at this, what is this doing? This is generating, I know I have 32 shards, so it's going to be generating an array with all of the numbers from 0 to 31 inclusive, and it's going to join that back with my table. What this does is this is a very efficient query to get me all of my last accesses by access time in the presence of sharding. Any questions on this pattern so far? Okay. So some intuition behind this. You can imagine that, kind of in the worst case, if I didn't do anything special to index my last access time, if I wanted to query that across my user tables, I would have to do a full table scan and sort in order to query that, in order to find the most recent accesses, for example. On the other hand, if I have an index that's specifically sorting by last access time, that's already stored in the correct way. This technique of using sharding is effectively an intermediary approach that gives me this ability to trade off how many shards I want to trade off my read performance versus my write performance. Where you can imagine here that here I'm, for each shard that I have, that shard I know is already sorted. And here I'm using the spanner query to effectively merge each shard, right? Each shard is sorted, I'm merging n sorted lists, in this case 32, which is going to be a lot more efficient than a full table scan, and also give me the right performance that I need by adjusting the number of shards. Okay. All right. Any questions on this? We can go on to the next topic.
Hi, I have a quick question. So instead of doing a unnest and generate array, if we just plainly do shard ID between 0 to 31 in the single SQL line query, will that be less efficient?
That's a really good question. So you can look at the query plan for that and make sure that it's doing what you want. If you look at the generated query plan for this, effectively, we only have one table scan at the end, where we're filling in this shard parameter. So yeah, you can play with the query and look at the plan and see what it generates for a shard ID between 0 and 32, or whatever your number is, and see if that gives you a good plan.
Hi, this is Guang, and I have a question about the sharding. So, for example, we have 100 terabytes of data. We create 100 of shard, but in the future we will have 200 terabytes of data. So, what should we do? Should we reshard to 200 shard, or the spanner will handle it for us?
Yeah, that's a great question. So really, the number of shards that you have is going to determine your write throughput, right? So you can have more data, and not affect the number of shards that you have, as long as your write throughput has not substantially increased. Now, if your write throughput has increased, then you may want to increase the number of shards. To do so, kind of coming back to my example of how I created the shard. These generated columns are a really nice way of creating these shards. You could create a new column using a different expression to give yourself more shards, and then a new index on that, and then switch your queries over to the new index. So that gives you a relatively easy way of getting to more shards if you find that you need them.
Okay,
so I feel like I could comment on that previous question.
Go ahead, Kendall.
So could you pop back to the query slide? So the question, if I understood correctly, was instead of writing this query as a join from the unnest join table, could it be written with a filter on the shard ID, saying where the shard ID is between 0, the shard is between 0 and 31? Is that correct? That's what the question was?
Yes, that was the question.
Yeah. So it's liable to be much less efficient. The example query here has a limit, which is very common, in fact. Often the limit number would be much smaller than 1,000. The reason that this structuring is fast to join is that the query can go, and let's say the limit was, for the most extreme case, limit 1, it can go into the table and get the top row for shard ID 0, and then the top row for shard ID 1 and the top row for shard ID 2, etc. So it will get a total of 32 rows. It will then take those 32 rows and sort them and take the top by last access, because they're all the sort of the highest last access value, order by last access descending, for each individual shard ID. So you get those individual 32 elements, sort them and take the top item if it was limit 1. Or indeed, if it was limit 3, you would take the top 3 for each distinct shard ID, and then take all of them together and do a sort and take the top 3 from the top 3 of the top 3s. But if you write the query without the join, simply with a filter, the query doesn't do that, and it ends up getting all the rows. It would end up getting all the rows and doing a full sort, in fact, of the entire table, more or less, entire table, and taking the top, sort of the final top 3. But by all means, go ahead and try it out and take a look at the plans, and that's what you'll see.
Great, thanks for explaining.
I hope it was reasonably clear. I actually have a set of slides I've used to explain this point in detail, but I haven't got time to sidetrack into that. But short answer is, yeah, this is what the join is more efficient.
Yeah, thanks for that detail. Yeah, I've actually used this pattern in practice a lot, and I've seen that it's very efficient as well. So yeah, remember this kind of pattern with the unnest and the join. This gives you a very efficient query plan. Okay, any other questions?
Yes. So can you go back to one slide? Yeah. So here the shared column, it is stored, which means that the data actually is saved in the database. So if we add a new shared column, how long it will take for the spanner to update the existing data with the new shard?
Yeah, so that would be a regular spanner schema change. This would be a backfilling schema change, so it may take some time. I think one interesting property of spanner schema changes is that although they may take some time, say that you're adding an index or adding a new generated column, however, they're always live changes. Okay. So that means that it may take some time, right? You may have to wait for this to happen, but you can continue serving while this is happening, right? So there's as long as you're willing to wait, you can continue operating your database as normal.
Okay. Okay. Thanks.
Yeah, and it should be proportional to how much data you have and how many nodes you have in your instance.
Hey, John, this is Roy. There's a request in the chat in this window.
I see. To patterns with columns of a composite key. I do touch on this in the end briefly, so we'll try to get to that if we have time. Thanks for the question. Okay, so next topic. This is a relatively straightforward one, although I see it a lot. This applies to essentially almost any relational database, including Spanner. In Spanner, it may be even more prominent, just given that you may be dealing with larger data volumes, larger scale than you normally would with other databases, but this is a common thing. Say that I have some table where I am paginating my results, and I'm attempting to paginate by limit and offset. I want to return pages to the user of size 100, and then I'm going to give an offset of what the last page was of that number. The problem with this is that in order to reach that page, I end up doing a linear scan, right? So if I end up returning all results here eventually, I end up going to effectively be doing n-squared work. This one, it's the same technique to avoid this one as you would use in other databases. What you want to do here, you want to paginate by key. Sorry, the offset should be removed here. It's an error in the slide. You want to paginate by key instead of by offset. Let me fix that. And this is efficient. Spanner can effectively seek to that last key that you specify. You can use the same technique if you're querying by index. And then finally, this gets a little bit more complicated if you have a composite key. If my key is A, B, I have to write a disjunction here to actually paginate lexicographically across that last key. But it's a standard technique, and you can look up what that form looks like. And as you add more components to your composite key, your query will get a little bit longer, but Spanner will implement that efficiently. So just keep that in mind. Any questions on this pattern? Okay, moving on. Index query performance. This is a really important one. And this comes up a lot too in serving applications, especially things that are very latency sensitive. Right, so like any other databases, indexes in Spanner allow us to efficiently look up values for specific columns. Spanner implements indexes as tables, and these tables contain the index keys, the base table keys, and any stored columns. Right, so imagine that we have the schema on the right here. We have this orders table. It's keyed by order ID, and then we have this index here that we have this orders by product, and the key that we're specifying here on this index is the product ID. We also know, based on how Spanner works, that this will be effectively implemented by a table, which will be key by product ID, and then coming back to its base table, it will have the order ID there as well. So let's look at some example queries here where we want to use this index very effectively. Right, so say that we start with this query here. We're doing a select star from orders by product. We're selecting a specific product and ordering by this order ID. Right, so the idea here is that we have, we're looking at a specific product. We want to see how many orders involve this product, right? Relatively straightforward. This looks fine. We're using the index. Our query is based on a key prefix of the index itself, right? So it's relatively efficient, but we can do better, right? And the reason why is that the ordering of this index, the clustering of this index, is very different than the clustering of my base table, right? What's going to happen in practice is that, as I'm returning lots of orders for my specific product, Spanner is going to have to do effectively point lookups all over your database in order to find all of the columns in the order table associated with this particular product, right? Because the index here, as we just described, only has the product ID column and the order ID column. How can we improve on this? This operation is called a backjoin, right? Where you query based on an index, but we also have to involve the base table as well. So a few techniques that we can use here. One, only select the columns that you actually need in the result, right? Select star can be expensive. So here, let's say that I've determined that my query actually only needs the order ID and this order info column. I'm just going to select those instead of selecting star. Otherwise, the query is the same. However, here I've made a change to my index, right? Order info would not be present in the index by default, so I'm going to add it to this storing clause. What this allows me to do is this changes my my effective query plan implementation from a join between the index and its base table into just a range scan of my my index itself. If you do a query plan for the before and after state, the difference can be huge. Here on the left side, we see the query plan generated for my original case, where I'm just naively selecting everything from the index. I'm joining back to the base table for each result. And on the right side, I have the final result. This increases in importance depending on how latency sensitive you are and how many rows you're returning. Right? You can imagine here, if my query is only giving me one row, then doing 2 lookups is not too bad. Doesn't make a big difference. But if I'm returning 1,000 rows, well, without this optimization, I'm effectively what Spanner is doing here is it's reading 1,000 rows from the index, and then for each of those, it's looking back into your base table to figure out the rest of the columns that are needed, right, and then returning those, right. So that's going to be a lot slower, right. So depending on your application, this can be a very, very important optimization. Questions on this?
If we look at the query, it mentioned in from clause, it mentioned the index name. Is that a typo or is it supposed to be?
Oh yeah, sorry, that is a typo. That should be that should just be the table name, yeah, with a force index clause. Yeah, sorry. Something like that. Force index is optional. Spanner now has a cost-based query optimizer, but you can always profile your query and see if it's doing what you expect. If not, you can add the index int. Other questions?
In Spanner, is explain plan same as the runtime?
You can do both. You can do an explain and you can do a profile. if you're just, if you can run the query, it's always useful just to do a profile because it'll show you, how many rows were scanned at each step and give you actual timings. So that can be more useful. Just doing explain if you just want to see the structure of the plan, that can be useful too. So it depends on what you're, specifically what you're looking to get, if that answers your question.
Yes, excuse me. In many tuning situations, we need to know where the inefficiency is. Is there something like a wait event interface, like in Oracle? It's called the Oracle wait interface. That way it knows I'm spending so much time in this disk operation and so on, so things like that.
Yeah, so the spanner query profile will show you some timings about relatively how long it's spent in each part of the plan.
Okay.
So you can get that from there.
Thank you.
Okay. Any other questions on this pattern? Okay. Next pattern. Here's a common one that I see, and this one is often this one's more of an artifact of the fact that spanner is strictly serializable, and oftentimes people are used to writing applications against databases with a less strict isolation level. So here, this is a pattern involving transactional event processing. So let's say that I have a table here where I'm tracking events. Events are keyed by ID. Maybe there's a ready column saying whether or not this event is ready to be processed. Maybe I have some additional info here. And a common pattern that I see, say that I have a bunch of workers that are running, they're using transactions. And within that transaction, I'm running a query where I'm doing select star from events, where ready equals true, limit 10, right? So I'm trying to find the next 10 ready events. And then for each of these events, I'm going to do some kind of processing on that event, maybe make some manipulation back to the table, maybe delete that event because I'm done processing it, and then commit the transaction. So the problem here is that the lock range here that spanner needs to acquire to execute this query effectively contains the whole table. The limit here isn't really helping us in terms of the concurrency that we can express. So in practice, what's going to happen here is that I'm only going to effectively be able to run one of these operations at a time. Maybe that's okay for your application, but if you're trying to scale and process lots of things concurrently, that can be a problem for you. So a common pattern that we use, we even use this internally in Spanner's implementation in many places, is that we use, you can use a snapshot, a query outside of this transaction to identify which rows I want to process. In Spanner, read-only transactions do not acquire locks, so they can all operate concurrently. And then once I've identified a set of rows, I can reread these rows within a transaction to recheck the current state, make sure that I still want to process them, right, to avoid any kind of concurrency problems or problems with different workers processing the same row multiple times. And then finally, in that transaction, if I've identified that it should be reprocessed, then I can make the change that I need to do. So what this looks like is, as I described, outside the transaction, I'm going to find my events. I'm going to get, say, the next 10 events, up to 10 events. Then within a transaction runner for each event, I'm going to reread that event, selecting by a specific key. Here, this point lookup, right, as we call it, I'm selecting a specific event, which means that I'm only acquiring a lock on this one event, right, meaning that everything else is able to acquire a specific lock on other events without conflicting. Finally, I rerun my check and then process the event and delete it or whatever I need to do with that. As an exercise to the viewer, I can also do batching here. I could do an in clause here and process all 10 events that I got in the same transaction if I wanted to. That's still efficient. What I really want to avoid is this whole selecting my entire table with a limit within a transaction if I'm concerned about concurrency. Okay. Any questions on this pattern? No? Okay, you have to stay here. I think if you're working, if you're writing this kind of work processing type pattern, there are a few more things that you can think about. You might want to think about schemes in which your workers can kind of find different events to process from your table, so they don't conflict. But overall, yeah, this can be a very deep subject, but I think this is a good starting point in order to allow concurrency in your operations. Okay, finally, a bunch of miscellaneous tips. Yes, go ahead.
Sorry, just a small question there. Is it an anti-pattern to do anything like any processing that will go to another system within that transaction? So for instance, if I was pushing a message to PubSub, would that be considered an anti-pattern as well?
That's a really good question. So it depends. What we have to keep in mind here is that just because you've required a read lock on something in Spanner doesn't actually provide you any guarantees. So the guarantee that Spanner makes is that after the commit has completed, that your read locks were valid. So you can do this kind of thing where you can interact with other systems within your transaction. You have to make sure that your transaction doesn't become idle, and Spanner will import it for that reason. But what you need to make sure is that this processing is idempotent, meaning that it can happen multiple times. And if you're able to handle that, then that pattern can work. But yes, it's definitely a good point. It's definitely something to be careful with because just because you've acquired the read lock via the query, doesn't mean that you actually have a lock.
Got it. Thanks.
Okay, and then finally, some miscellaneous tips. Somebody had already asked about composite keys. This is another really important one. I see this all the time, and users asking about performance issues. The important thing here is to understand composite keys. Spanner is similar to other relational databases in that you can define a composite key, and it will order your table by the lexicographical ordering of that composite key. In general, operations against a table where you specify a prefix range of your composite key is going to be efficient. And things where you're not specifying a prefix range of your table, it's going to involve a full table scan, and it's not going to be scalable. So you really want to be aware of that. This means things like primary key A comma B is very different from primary key B comma A. Right? Primary key A comma B is going to give me efficient operations against the prefix A. And correspondingly, primary key B comma A will give me efficient operation against B, and not vice versa. This also applies to indexes, right? So the order that I specify my index keys is also very important. On the topic of indexes, using indexes effectively is very important. Because Spanner is a distributed system, when I add lots of indexes, the expense of writing to my table can often be surprising, oftentimes more than other databases. That's because each not interleaved index is going to add transaction participants, right? So if I kind of blindly index all columns, whether or not I need that with individual indexes, then you're not going to be using the system as efficiently. Along those lines, when you're thinking about indexes, you want to add indexes based on the important query patterns that you have, right? So use the query statistics, use the query profiler, look at what your expensive queries are, and build indexes based on that. This is not that different from other databases. It's just that with Spanner, oftentimes you're talking about larger scale, so this becomes even more important. Next, build a staging environment with representative data. Just general great software engineering practice. Have an environment that has representative data that you can really test things against. Test things like ACLs, test things like different queries, schema changes. Do that there before it hits production. That's kind of obvious to a lot of people. And then finally, when you do have performance problems, you can use Cloud Spanner's introspection tools to debug performance issues. This is an area that Cloud Spanner has released a lot of tools in recently. So if you haven't looked at what's available recently, you might want to take another look. But at this point, we have statistics on reads, on queries, on transactions, and on locks. So these can be really useful in actually debugging your performance issues. Okay. Any questions on these topics?
Hey, John, this is Roy. I just want to make sure that you got to the comment in the chat box.
So for the pagination query pattern, does using greater than the last return ID still work if the primary key is bit reversed? So here you would want to ensure that you've bit reversed your query parameter as well, right? You want those to be operating on the same space. And if so, a spanner wouldn't actually know that your key is bit reversed, right? It just is a key, right? So you want to make sure that they're going in the same order and operating in the same space. Very good question. Okay. I have some further reading links here. All of these things are covered in spanner guides, best practices, and blog posts. And yeah, happy to take any additional questions.
John, this is Neil from Macy's.
Hi.
Hi. In our spanner database, more often we see the write errors. When it's because spanner is automatically retry those, if anything, to try to write it, and then they couldn't complete it. And sometimes there are many. So especially during batch window, we see that a lot of write errors. And then we couldn't figure out exactly what was causing this, and how does that write errors works, and then how the retry works, and then how many times it retry. Can you just give us any insight on that?
Yeah. Spanner clients are architected to give you an interface like a transaction runner, where it will keep running your transaction body until either it completes, or you throw some terminal error, or you hit a provided deadline. This is intentional because a lot of things in Spanner can cause transactions to abort, oftentimes much more so than other databases. So for example, things like lock conflicts can cause transaction aborts, but Spanner's transaction protocol is optimized for eventual transaction completeness. So that means that even if you are seeing transaction aborts due to lock conflict, Spanner will prioritize older transactions to eventually allow each transaction to complete. Oftentimes, transactions can abort for other reasons, like internal things happening in your Spanner instance, like leaders changing or other things. But that's why they give the interfaces that we do, to allow your transactions to complete without having to worry too much about it. I think kind of as a user of the system, that the most common thing that you can look into to kind of reduce the rate of transaction retries is look at your lock conflicts. Make sure that you're not getting lock conflicts, and also correspondingly that you're following the advice on reducing lock scopes where feasible. Say not locking entire tables, only locking the actual prefixes that you need for the query. Directly, the Spanner transaction runners, there's no limit on the number of times they can retry. It's based on deadlines.
Okay. So I do have some more questions, and then I'm going to give a chance to somebody to speak first.
Yeah. Hi, John. This is Guan again, and I have one question. We have a table which has 20 billion rows, and the people always ask, what's the data in the latest 1 hour, or latest 1 day, or latest 1 week, or yeah. And also, we only just need to keep the data 6 months old of data. So any data which is older than 6 months, we need to just delete them, because we want to save some money. We don't need the old history data. So how can we handle those kind of situation? The table is big, is about 20 terabytes, which have 20 million rows.
Yeah, that's a really good question. I think that it's probably beyond the scope of something that I can answer in the context of this presentation. encourage you to follow up. If you have a particular representative that you're working with, they can kind of get in touch with us, and we can talk about best patterns, best practices there. But yeah, I think that's probably a pretty involved schema and application design question.
Okay. Thanks.
Does the spanner provide partitioning, like range partitioning, hash partitioning, or list partitioning like that?
So Spanner automatically partitions all of your data by range. This is not something that, as a user of the system, you necessarily have to worry about. In the end, you should just see that it's, it can scale, right? You don't have to worry about how it's partitioning your data. But there's no kind of explicit, partitioning function, right? It partitions by key.
So I have one more question, John. To matter of fact, I have two questions. Okay, and one is, so you said the index has a storing option. So I'm assuming that's going to be additional storage, because
that's correct.
Think it's storage. Okay, so that's my assumption. And the second question is, if I look at the spanner, I only see selects. I don't see update. I don't see insert. I don't see delete statistics. There is no information about any other transaction other select. Why is that? Or
I see.
Yes.
Yeah, I'm not sure about the roadmap. I think that is something that we are thinking about. So thanks for bringing that up. Okay. That's all the content I had. Thanks for attending.
If no one has other questions, I have one more small question on locking. Does the spanner provide pessimistic locking or optimistic locking? Pessimistic locking, in many situations, there will be a situation like, okay, if I don't get a lock on the rows that I'm going to operate on, throw the exception and I will handle it. So what is the locking mechanism in Spanner?
Yeah, so Spanner does use pessimistic locking.
Okay.
Spanner won't throw an exception specifically due to locks. What you will see one of two behaviors. Either your transaction will block while it tries to acquire that lock, or in the case of deadlock, Spanner will throw an aborted exception. So depending on the actual pattern that you're using of your transactions, you'll see one of those two.
Regarding partitions, right? Most of the time, business queries will depend on, okay, show me my orders in the last day or last week or something like that. Very few times people query on the key. The keys are used mainly in the joins. Mainly keys are surrogate keys, and they actually don't have much business meaning in it.
Yeah, you could either consider folding that into your table key, or you could structure your indexes to be effective in that scenario.
A very basic question I wanted to ask on the composite keys. Let's say if I have a composite key involving column A, B, and C, and in some of my queries, I can only provide A and B. So is it recommended to create another index just with A and B, or having a composite index with A, B, C is enough?
A, B, and C is enough. As long as you're querying a prefix of your key, then it should be efficient.
Okay, thank you.
John, I have another question. So I saw that you mentioned the interleaved in the table schema. So if I have two tables, what's the difference? What's the performance difference of those two tables created without the interleave, with the interleave? What's such an easier to select the difference performance?
Yeah, so that's another really good question. The main thing that interleaving gives you is it gives you really efficient joins between these tables. So if your common access pattern is to join a table with its, with a potential child table, then that's a really good candidate for interleaving. On the other hand, if that's not your primary access pattern, then interleaving probably doesn't make as much sense, right? So really, like it's about this kind of join optimization. Also there's this kind of implicit pseudo foreign key as well, where the child table, effectively the rows there are interleaved under a specific parent table row, right? So you kind of get that data integrity property as well.
Okay, so for the interleaved table, so is the speed is 2 times or 3 times or 10 times faster than the uninterleaved table?
That's really going to vary. I don't think that there's one specific answer there. I recommend benchmarking there. I think that's going to be highly dependent on your schema, your query pattern, etc.
Okay, thanks. By the way, this is a great
sorry.
presentation. Thanks a lot.
Thank you. Yeah, I mean, the overall advice that I have for interleaving is, yeah, kind of look at your access patterns, and see like when that locality is going to be helpful to you, right? When you're joining between those tables. Okay. All right. Thanks everybody. Hope to see you at the next meetup.
All right. Thank you, everyone. Thank you, John. I will stop
Thank you very much,
recording.
John.